Welcome to The Explainer. Today we are focusing on a concept we call the last samurai, mastering the paper. We are going to turn the Cambridge 9618 computer science exam into your personal, highly strategic battleground. Just like an ancient warrior mastering their blade, you need absolute precision to slice through these exam questions. Specifically, we're zeroing in on one of the most notoriously tricky, mark-dropping areas of the entire syllabus, justifying the use of data structures, stacks, queues, and linked lists. If you have ever stared blankly at a complex data structures question, your mind racing, wondering exactly what the examiner was to see, trust me, you are in the exact right place. We are going to break down exactly how to secure those top-tier marks using insider intelligence straight from the source material and the principal examiner reports. Let's get right into it.
So, let's start with the ultimate question. Why do so many students find applying data structure concepts to unfamiliar contexts so incredibly hard? To explain this, I want you to imagine two typical students sitting for this exam. We'll call them Alex and Sam. Now, Alex studies hard. Alex overloads their brain with raw computer science facts, memorizing every textbook definition of a stack or a queue, but offers zero critical analysis when writing the answer. On the other hand, we have Sam. Sam knows the material, but rushes. Sam sees a keyword, panics, completely misses the actual command word requirements in the prompt, and just word vomits everything they know. If you were to look at their papers side by side, it's just a sea of red pen marks from the examiner. Why? Because the difference between an average grade, like a B, and that coveted A star comes down to this single, crucial challenge. It's the hurdle of taking a rigid theoretical structure, whether it's a last-in first-out stack or a first-in first-out queue, and seamlessly adapting it to a completely new, unfamiliar, and frankly weird context that Cambridge throws at you on exam day. Examiners know this is the ultimate test of true understanding. Today, we are going to fix both Alex and Sam's mistakes and give you the absolute blueprint to conquer this paper.
Here is our strategic agenda for today's explainer. First, we'll tackle the unfamiliar context challenge. Second, we'll build the core theoretical principles. Third, we unlock the method mark strategy. Fourth, we'll navigate the top 3 examiner warnings. And finally, we'll master critical analysis and evaluation.
All right, Section 1, the unfamiliar context challenge. Let's talk about encoding the concepts.
Now this right here beautifully illustrates why rote memorization, like our student Alex was doing, just does not cut it. The assessment objectives for the Cambridge 9618 exam are strictly designed to target 3 very distinct cognitive domains. Notice how these domains act like a staircase. At the very bottom step, you have basic knowledge and understanding. This is knowing what a linked list is. But the marks quickly scale up as you climb into the second domain, application. This is where you actually use that structure in a specific scenario. And finally, at the very top of the stairs, the peak of the mountain is analysis, where you evaluate exactly why that specific structure is the absolute best choice. Just memorizing raw facts won't save you when the examiner asks you to climb all the way to the top and analyze a complex system. To get there, you need to decode the command words. Are they asking you to state, describe, or evaluate? Top students structure their answers using the PEL framework, point, evidence, explanation, link. You make your point about the data structure, provide evidence from the scenario, explain the technical mechanism, and link it back to the specific problem. It is a game changer.
To master these unfamiliar contexts and effectively use frameworks like PEL, the source material explicitly recommends a powerful memory hack using a visual story method. Instead of trying to painfully recall a dry paragraph of text during a highly stressful exam, you visualize the structure in the real world. Picture a massive teetering stack of heavy dinner plates in a restaurant kitchen. If you want a plate, you have to take the top one. The last in is the first out, LIFO. Now visualize a long line of people waiting outside a cinema in the freezing rain. The first person who got there is the first one let inside. First in, first out, FIFO for cues. This vivid visual encoding creates immense mental flexibility, allowing you to instantly map these structures onto whatever crazy context the examiner throws at you. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, Core Theoretical Principles, the architecture of a perfect answer.
Listen up, because we have a major examiner alert here. Principal examiner reports issue a massive, glaring warning that candidates consistently bleed easy marks because they confuse key terminology. Think back to our student Sam rushing through the paper. Sam might write something vague like, the data goes to the next piece of data.
Absolutely not. You will get 0 marks for that. It is absolutely vital to define your terms clearly before deploying them in your extended responses. You need to use precise words. Don't assume the examiner knows that you know what a pointer, a node, or null terminator is. State it clearly. Laying that initial solid groundwork proves your fundamental understanding before you start building those complex analytical arguments.
The theoretical architecture of a top-tier answer